Hi, this is Mr. Lonergan, and this is SAT packet number 6, question number 9. The best strategy for dealing with this problem is this. Skip it. However, if you are undeterred, let's take a look at how you might attack this. First thing is to look at the information in the problem. We know that p, t, x, and y are all positive integers. That means whole numbers, no decimals, all bigger than 0. P to the x power equals t to the y power, and there's this interesting relationship, x minus y equals 3. Why do I hate this problem so much? First of all, you got 4 variables, lots of chances for error. Second of all, look at the problem closely. That word cannot means that there are 4 right answers in here and only 1 wrong answer. So it's another case where we have to do the problem more than one time to figure out what the SAT answer is. Doesn't seem worth our time. But if you want to stick with me, I'll explain how you can do it. For me, the key piece of information was this right here. X minus y equals 3. If I wanted to rewrite that relationship, I could say it like this, that y plus 3 equals x. And I could even rewrite my original problem like this. P to the x equals t to the y becomes p to the y plus 3 equals t to the y. As I go through this scenario, I can remember, So from here, let's talk about what I would do. I might first go to the answer choices and say, from choice A, B, C, D, or E, which ones can I do? The first choice, choice A, says, what if 1 is the value for t? So let's try it. If t equals 1, can I get an equation that works? Let's see. P to the y plus 3 equals 1 to the y. Well, really, y could be any number. Let's say, it doesn't really matter. Y could be any number. As long as p was also equal to 1, I would know that that is true, which means that answer A is not our wrong answer. The other possibilities were 2, 4, 9, and 25. As I look through that list of numbers, I notice one that sticks out. These 4 are perfect squares. This one is not a perfect square. So that's going to be the next one I would try. When I tried t equal to 2, let's see what happens. I'd say p to the y plus 3 equals 2 to the y. Well, here's where my common sense alarm kicked in. 2 to the y power equals some number p to a bigger power. And since these are all positive integers, that means p to the y plus 3, or y plus 3 is bigger than y. So then what could p be? Can p equal 1? No, because then p to the y plus 3 would equal 1. That would only work if y was equal to 0. So p can't equal 1. Can p equal 2? Well, that doesn't quite make sense either. Then we'd have 2 to the y plus 3 equals 2 to the y. Those are unequal, but we're saying that they're equal. So that can't work. Can p be anything bigger than 2? Well, let's look. 3 to the y plus 3, can that equal 2 to the y? Look at the fundamental error here. The base is bigger on the left, and the exponent is bigger on the left as well. So there's no way that these two could be equal. So p, if t is 2, look what happens. P can't be a smaller integer. It can't be the same integer. And if it's 3 or anything bigger, it won't work either. So the answer that cannot possibly work is choice B. Now, if you are really a glutton for punishment, I will explain about these other choices. But for most of you, you should press stop now. Okay. If you're still with me, let's talk about how some of these other answers would work. Can t equal 4 or 9 or 25? The answer is yes, it can. We're going to use this substitution for each of these. We're going to let y equal 3, which means x equals 6. I jump to this because I know that x and y are 3 apart from each other. And I like this relationship right here. Things that are 3 apart but also doubled. Okay? When I look at this now, I can say, for example, t to the 4, I can say, p to the 6th equals 4 to the 4th power. Here's where my calculator comes in. Clear. 4 to the 4th power equals 256. Whoops. Let's be careful, Lonergan. Not t to the 4th, t to the 3rd power. 4 to the 3rd power equals 64. Is there something to the 6th power that equals 64? My calculator can help me out. I would say p equals 64 to the 1/6 power, the 6th root of 64. So I'm going to try that on my calculator. 64 to the 1 divided by 6, and I get an integer value of 2. So when t equals 4, p equals 2. And what's going to happen is that each one of these numbers, when I plug it in, I'm going to get the square root. So when t equals 9, I'm going to get eventually that p equals 3. And when t equals 25, I'm eventually going to get that p equals 5. So all of these scenarios are possible. I'm not sure how on a 20-minute test you'd be able to jump to this place and know for sure that they're possible. But I do think with a little bit of thinking and number sense, you would be able to see that 2 is impossible. Okay, now I'm really, really done. Stop watching and go do something more productive with your time.